Hello everyone, this is Grace. It is October the 19th, 2021. And today we're going to be discussing the moon. This is a follow-up video to my videos, the original video that I did on the moon, as well as the moon is a disk and 12 hours day, 12 hours night. You'll want to watch all three of those videos in order to get a full picture of what's going on here, but you don't need to watch any of them. Basically, this is just a little something extra that I'm doing to add on to those videos because you guys seem to really like those videos. So I came across a demonstration of the moon's orbit and the phases of the moon, an actual experiment that was done. And I made some observations and I wanted to share those with you. So let's go ahead and get to it. Okay, so the name of the video that I saw was Moon Phases Demonstration, and it was by National Science Teaching Association. I'll put the link in the description box. So what happened during the experiment, what she did was she had a ball, like a styrofoam ball or something. It wasn't styrofoam, it was much smoother, but it was similar. And she stuck a pencil in the bottom of the ball, and she held it out arm's length, and there was a light in the room. It was dim, it wasn't dark, but the lights were kind of turned down, and there was like a soft light in the room which she used as the sun. And she held the ball up at arm's length, and then she spun around in a circle holding her arm at arm's length, showing the different phases of the moon and how the light hit the ball as she twirled around in a circle with her arms stretched out. And in that way, she showed you all of the phases of the moon. Now, I made some observations for each of the phases, and then I have some additional observations as well, which I'll share afterwards. So the first thing she showed was actually, now that I think about it, was the new moon. I didn't make any comments on that though, but I will in my observations at the end. So the crescent moon was the second phase or whatever. And what I noticed was she had the ball high so that no light hit the bottom of the ball. So it was dark at the bottom. The light is reflecting off of the top and not the bottom. The light is overflowing and highlighting the opposite side of the ball as well to form two crescents, one regular on the lighter and regular, and a lighter crescent was formed on the top on the opposite side of the ball. So you had a really bright crescent from the light bulb that was in the room, but there was some kind of overflow or something that caused the top of the ball to be highlighted as well, so that there was another crescent at the top as well, making a ring of light around the upper portion of the ball and leaving only the very center bottom of the ball not lit up. So then she moved on a little further to the quarter moon. And I noticed that it wasn't a perfect half, but I didn't know if it wasn't a perfect half. It seemed to me logically that she should have been able to make a perfect half out of that ball. So I thought it was very odd that hers wasn't a perfect half. So I had to mention it because where the pencil was, it was all shadows. Where she had the pencil holding up. And I thought to myself, well, that doesn't look right. There's something, I don't know if she needed to go closer or further away, but there was something wrong because logically speaking, she should have been able to make half of it lit and half of it in the shadows. Either way, I noticed it, so I wrote it down. The shadows were very obvious on the quarter moon. The light and shadows make a tilted X pattern. Oh, okay. It was darker down the center, right? And then what I noticed was there was like a V-shaped pattern at the top, and then a V-shaped pattern on the opposite side on the bottom. And it kind of made a tilted X pattern. Like there was a line, there was the line going in the center, and then there was another line going across that line, making it into like an X. And that's what the shadows did when she held the ball up in the quarter moon section. So then the Gibeous Moon. Now the Gibeous Moon is the one, now that she did show that it was possible. It's the one that I did not think was possible, but it is possible, and she showed that in the experiment. However, you don't see it in real life, not for a moon, and you barely see it in pictures. They don't even really show pictures of it that much. Anyway, the Gibeous Moon. That is what you might want to call the 3/4 moon, and let me show you the picture of it. Hold on, so you'll know what I'm talking about. Here we go. Well, it's taking a second to clear up here. Here we go. So the Gibeous Moon, it's kind of like this. This may be closer to a half moon, but it has more of a circle in the center there. Okay, so this is the one that I didn't think was possible. The half moon is, you don't really ever see that either, but that is possible even in the scenario that I presented. So I don't really mind that one so much, but you don't really see this, not where it goes in like that. But anyway, here's what my observations were. The white spot was clear on the Gibeous Moon, and what I mean, let me show you what I mean by the white spot here, because we talked about that when we looked at the balls. Here we are, right here, where it was white, where the light hits it first, and then it spreads out. Where the Gibeous Moon went on her ball looked exactly like this. You saw the white spot in the center, and then around the sides it was dark almost all the way around. And then it was lighter in the middle. It didn't look like a moon. It looked like a ball would look in the light. But I'll read it for you. The white spot is clear on Gibeous Moon. Shadows match those of a ball, but not of the pictures of the moon. They get darker as they go out from the white spot. It's not seen in real life. So anyway, then the full moon. The full moon is further away and darker than the crescent, but it's very, very bright in real life. You can see how much darker that full moon was when as compared to the crescent if you go and watch that video. And I hope that you do. I don't know if they'll take it down. I don't know if they'll Photoshop it and change it. I don't know what they'll do, but I hope you'll go and see it as soon as possible before they make any changes, which they may have already made them. I don't know. But either way, the full moon was further away, and it was far darker than the light on the crescent. But in real life, the full moon is very, very bright. Is very bright. The shadows were obvious on the full moon. You can see the shadows in the dent in the ball. You can see the shadows on the bottom and on the sides. They curve up to the top, which is entirely lit up. The top and bottom were not lit up evenly because of the shadows and the alleged tilt. Her tilts in her experiment, they were very subtle. I wasn't sure if she was doing it on purpose or if she was trying to compensate for what they say was a tilt, but pretty much it seemed she was trying to keep it parallel to her at all times. It just didn't work out that way. So some of the faults were that she used a white ball, and I'm not saying that the white ball was wrong. I don't know. I'm just saying that it might have been better to maybe do a comparison. But since this is the only experiment that I've actually seen done, I'm grateful for it. So a white ball, maybe even a black ball could have been done for comparison. But we'll take what we can get, right? She had a regular background instead of a dark background. She did it in her in a room, a regular room, you know, that was with paint on the walls, right? It wasn't black. But that's okay. It doesn't matter. But what rendered it, what rendered it useless really was that she held the ball out perfectly parallel to the sun, pretty much as parallel as she could get it, and then she spun it around. And that's not the way the moon actually rotates. But even though there were flaws in the experiment, I was still able to make some observations from it, and I wanted to share those with you as well. Okay. First, the theory fails to properly place perspective in its reasoning, and therefore it was rendered illogical. And I'm talking about the theory of the moon circulating the earth. I'm talking about their theory. It's illogical. Now, what do I mean by it fails to properly place perspective in its reasoning? Let's look at one of my graphics here. Let's look at this one. Okay. So we have the sun, we have the earth, and we have the moon. If you have your moon, let's look at the crescent. I'm going to talk a little bit more about this later because I put this on the list. Well, first I want to give you an example of real life. If you are in real life and you're driving down the street and you come to a house, say the house is the earth and the moon is you in your car. As you drive down the street and you pass by that house, first you see the one side of the house, then you see the front of the house, and then you see the other side of the house. It's not going to be any different if you're sitting at the house watching the cars go by. First you'll see the front of the car, then you'll see the side of the car, then you'll see the back of the car. However, what they want us to believe is that everyone is facing this moon at the exact same time. Everyone on the planet is looking at this moon from this exact same perspective, and that is not correct, and nor is it possible. Not from their theory. Now, our theory says there is going to be an exception where you won't need the perspective. If there's something directly in front of this moon or something like touching it or placed on it, then everyone will see the exact same moon at the exact same time. But since they only have half of it being seen because of the light, depending upon where the moon is placed, like if it's placed here, only there will be an imaginary line drawn here, and only these people could see it. Only these people could see it. See? But there's a problem with that. But hold on, we'll go into that a little bit more later. Their reasoning is incorrect. The logic doesn't place into perspective that you are going to see a different portion of the moon depending upon where you are in the world. And since they say you only see one side of the moon, it doesn't work. It just doesn't. It's illogical. So let's move on. The sunlight does not only light up the earth. The sun continues to radiate through the room and onto the moon. Another thing they tell us, when you see the graphics, which is what we normally see, right? They'll show this graphic and there'll be one ray of sun and it shines on the earth and then it stops. And they never show you the sun shining out on the earth and the moon at the same time. The only time it shines on the earth and the moon at the same time is when it's a new moon or when it's a full moon, so that it's perfectly in line with earth, so that you're not thinking, hold on a minute, there's sun radiating throughout everywhere. That's the way she did the experiment in the room is real life. The sun doesn't just hit earth and stop. It can't. Otherwise, it wouldn't be hitting the moon. It hits the earth, it hits the moon, and it continues on into outer space. If you keep that in mind, what you will notice is that you would be able to see the entire moon based on the light that is radiating in front of the ball, just as you are able to see the entire ball in her experiment throughout the entire experiment. There are shadows cast on the ball, sure enough, but the light that's radiating throughout the room is enough for you to see the entire ball. Now, true enough, she did not do it in a dark room, as what they call outer space is dark. But you can get a flashlight, take it in a dark room, and you can see that even if you can't see the entire object, you can see the shadows, you can get some idea what the object is. It's not just nothingness there. It's not just nothing there. That doesn't happen. Plus, we don't see any evidence of the sun shining in the sky. When the moon is there, we don't see any evidence. All we see is a moon and moonlight. That's all we see. Where is the sun radiating at? Well, it's not, but we're going to get to that later. According to their reasoning, because the crescent moon is manifested beyond the center point of Earth, that imaginary line I just showed you, it cannot be seen by the other half. Therefore, it should be visible during the daytime hours only, never during the night. I'll show you what I mean. Okay, the crescent moon here is here. So you have your imaginary line drawn here, right? For the half of the world that can see it. However, this half is facing the sun. It's on the half, and it's either here, the crescent is either here or here, according to her experiment. So you're always going to have to face the sun. So if it's night where you are, then you're not ever going to be able to see a crescent moon because it's facing the sun. Do you see? Even though you should be able to see it because it's on your half because it's here, and so you have your imaginary line drawn here, or if it's here, then you would have your imaginary line drawn here on the half of the world that can see it, right? So even though you should be able to see it, you would have to actually be able to see the sun at night in order to see the moon. So I can't make logical sense out of that. I don't know if you can, but it's obvious that it's facing the sun. It's on the side of the planet that faces the sun. So this part is rendered completely useless, and only this quarter here and then this quarter here will be able to ever see this crescent moon. As you spin around the earth and the sun comes up, then you should be able to see the crescent moon. Same for this side. You will never see it at dark, at nighttime, never. Because when it goes up here, it goes from the crescent to the half moon to the gibeous. And when it's a gibeous moon, you'll see it at night, but never a crescent. The sun hits it differently. You'll have to go watch the experiment to understand perfectly what I'm saying. But the sun hits the ball for a crescent moon when it's just a little bit out from the sun and facing us. And then it goes to the half moon, then it goes to the gibeous, then it goes to the full moon. And the new moon, of course, is right here. That was the way she showed us the experiment. So it's not possible to have a crescent moon at dark. Okay, the full and the gibeous moon should be visible at night, never during the day. The quarter moon should be visible both day and night. It was kind of hard to work that out. It was just illogical. The logical view would be, the logical view is going to go according to your perspective. This isn't right, but this isn't right because you wouldn't be able to be far out enough to see a full moon, but I'll show you what I was speaking of. Okay, so if you have a half moon, so the line is right here, right? Because you can see half of it and then the other half can't see. This is their logic. You can see half of this ball. You can only see half of it at each as it rotates around. The other half you can't see. So this is the imaginary line. So it's sunny on this half of the earth. It's dark on this half of the earth. So logically speaking, they should both be able to see this. Right? They should both be able to see it. However, when you take perspective in, you would have to be right here in order to see half and half. Exactly. As you go out further away, then you're going to see more darkness here. And it's going to look more, even more like a crescent even. Because you're going to have more, hold on. If you see more darkness, yeah, it'll look more like a crescent on this side of the world. And at the same time, on this side of the world, it'll look more like a full moon because there's more light reflecting. I think that's right. Yeah, I'm not sure what's right. I bounce back and forth on that. You can put it together however you want to. The perspectives are going to be different. This is what I was trying to get at. The perspectives are always going to be different. And they didn't put that into their experiment or their studies. I've never seen it mentioned. They just talked as though in reality, everyone sees the exact same thing at the exact same time. Okay? That's the reality. We all have the same night. We all have the same day. We all have the same sky. Now, there are parts of the sky that you can't see, obviously, because the sun's on one part of the sky and the moon's on the other part of the sky. And depending upon where you are, it's going to vary, but it's still going to always be the same. And the sun and the moon are so far away that we just don't notice those changes pretty much at all. But in their particular case, you would have to notice it. You would have to notice that kind of a change if you're relying on the sunlight to render the different phases of the moon, because they have their phases changing every couple of days, every 2-3 days, I think they say, from a new moon to a crescent. Not sure. There's no difference between an eclipse. Hold on, did I do this one? Yeah. There's no difference between an eclipse and a new moon. Any change in the tilt of the moon would render a different view. This once again is perspective. It's so odd. Okay. So this is the earth right here. Of course, that's the sun. And then this is just different places of the moon. They say that the moon it rotates around the earth on a tilt. There is no way that the moon can rotate around the earth on a tilt and us not have a different view of it. It's absolutely impossible. You cannot be facing the moon at the exact same time all of the time. It's not logical. If it's up high here, then you're going to see more of it down, more of the bottom down below. When it's down low here, you're going to see more of the top as it goes down lower. When it's here, the perspective of this person here is they're going to see more of the top, and the person down here is going to see more of the bottom. It cannot be on a tilt and rotate around for the same reasons why I explained. If you're sitting at your house and a car drives by, you see a different perspective as it goes by. And don't say you won't always see it, because the sun doesn't just stop shining on the moon because of whatever reason they say. It's always shining. It's always radiating across. You should always see it, and you should especially see it when it's closest to the sun. And if you don't see it, then what you'll see is a black spot. You should see something. If they don't want to say another, and the new moon has to be an eclipse, because if it's not an eclipse, it requires some sort of shift in this tilt here. At the very least, if there's not a tilt, then every year you should be able to predict around such and such and such a time this year we're going to have an eclipse every year, because that's we rotate around the sun every year, and unless something changes, what changes to where the new moon doesn't become an eclipse, to where it becomes an eclipse? It's illogical. The whole thing is illogical. It's just a bunch of double talk is what it is. We're on one they're telling us they have one rotation for the orbit of the moon. Unless there's a different orbit, then we need to be having an eclipse every year at best. Every month, ideally, since every month it's supposed to be in front of the sun, blocking the sun. We don't see a spot there where the moon is. Just miraculously, the moon just somehow just disappears every month. Supposed to be in front of the sun, but just disappears. A great big giant moon. Where is it? Where is the moon? Why can't I see the moon? Don't tell me. I don't want to know. I don't want to study this stuff. I don't want to study science. I only watch these videos because they started popping up in my feed. And so I just started watching them. And so now they pop up on their own. I don't even think it's you guys. I know you like them. Like I said before at the beginning, you seem to like these videos. So I decided to do this to give you my observations. But look, I know the earth is flat. They can give me 1,000 explanations. All it's going to do is make me have to do something like this, where I have to work to explain it, because I have to know the truth. So I have to look and I have to think about it and I have to consider it, even though I know it's not true. You see what I'm saying? I know it's not true, but I can't just dismiss it. It's not fair to me to do that. So, yeah, I don't want to know. They may have an explanation. I don't want to know. I'll just have to consider it, and it's just lies. Anyway, when there's no eclipse, a new moon should be seen as a shadow in front of the sun. There should be no days when the moon is not seen. I think I explained both of those already. Did I explain that? I don't know if I did, but let's talk about it real quick. Okay, so if the moon is... Now, I say that there should be no days when the moon is not seen. However, keep in mind that I'm not considering this tilt here. That tilt that they use to explain why the northern and southern hemispheres doesn't receive as much light in the winter time. It could be that they could possibly use that to say, well, because of this tilt, you don't see the moon on these days and such and such and such. But logically speaking, I'm working on a 24-hour rotation of the sun. If the moon is here and they can see it from here on a 24-hour rotation, then the people on the other side should be able to see it come nighttime. If the moon is over here closer to the sun and it's nighttime over here, then when it rotates, and it's daylight, then the people when it's daylight, they should be able to see the same moon during the daylight hours. Again, you could probably do a little bit more research into that and find that there are some holes in that theory. But ideally, from what I can see, you should always be able to see the moon on a 24-hour rotation. Always. Okay. I did that. If the moon were on a tilted axis, it would provide different views of the top and bottom of the moon. Oh, I didn't do that. So I spoke about how you would have different views. Because it's on a tilted axis, when it's higher up, of course, you'll see the bottom. People here would see the bottom. When it's lower, of course, you'd see more of the top. We would have several different views of the moon if it's on a tilted axis. Not to mention the sides as it rotates around the Earth. According to their own reasoning, when the moon is below the center point of the Earth, then no one in the northern hemisphere will ever be able to see it. For example, there will never be a full moon. I think I talked about that already. Likewise, the southern hemisphere would ever see the moon in its opposite state. I spoke about that already when I was explaining the crescent. It would be the same for the full and the new moon. Because it's a new moon, only the people in the daytime would ever see that little dot or the eclipse or whatever they say it is, because the line is right here that divides it in half. So the people at night would never see it. And then the full moon, you should never see the full moon in the daytime, which we do. But I know they have an explanation for us seeing the full moon in the daytime. I don't remember what it was, but I've read it before. So they have an explanation for that, but it doesn't work the way she did her experiment, and it doesn't work in common sense. It just doesn't. You should not be able to see a fully lit moon, according to their theory, in the daytime, because it's on the other side of the planet. Not because it's not lit, but because it's on the other side of the planet. Not because it's lit, because it's on the other side of the planet. And that is all that I have for you. As I said before, let me give you the name of the video again that I was working off of. It's called Moon Phases Demonstration, and it's called National Science Teaching. The makers of it was National Science Teaching Association, and I'll include the link in the description. I did have a few other points that I wanted to point out, some things that I ran across. The tilt is about 5% from the orbit around the sun, and the Earth is 6 times larger than the moon. And that is all I have for you. I will see you in the next video.